Hello friends, today we are going to deal with the topic preparatory steps prior to finishing of textiles. What do you mean by preparatory processes? Yes, the fabric received as grey cloth from the loom have a lot of impurities present in them. These impurities may be natural or oils, waxes, dyes and dirty stains acquired during manufacture of the fabric. Complete removal or cleaning of these impurities is important before applying any other finish, as they may interfere with subsequent processes. The process of removal of these impurities is known as preparatory process. Preparation is important as success of all process such as dyeing, printing and finishing depend on it. Improper preparation will lead to poor performance and quality in the finished product. After completion of this module, you would have learned the definition and objectives of preparatory process, gained knowledge on the preparatory process suitable for different fibers with special reference to cotton, wool, silk, rayon and polyester. Become aware of the objects, importance and techniques of each preparatory process. Preparation can be defined as the process of preparing fiber, yarn or fabric for subsequent processes. It is a process of cleaning or removing impurities from the textile materials regardless of the fiber content and construction of the textiles. The primary goal of preparation is to remove impurities that will interfere with overall processing functions like dyeing and finishing. The other objectives are to improve the ability of fibers to absorb dyes and chemicals rapidly and uniformly, to produce a substrate that has uniform standards of white, minimum fiber damage and a constant pH. The typical preparation process in textiles are singeing, desiccing, scouring, bleaching, mercerizing, heat setting, wool carbonizing and degumming. All fibers will not undergo all the above said processes. The process sequence chosen will include only some of the process and they will be selected based on the product's end-use requirements, fiber content and the kind of impurities present. Impurities found on textile materials vary from one fiber to another. As the impurities vary, the process of removal also varies. For example, cotton is cured, silk is degummed and wool is carbonized. Let us have a detailed look into the preparatory process for cotton. In preparation for dyeing or printing and finishing, cotton raw fabric, also called grey cloth, is singed, dezicced, scoured, bleached and mercerized. These treatments remove natural non-cellulosic constituents or impurities and increase the affinity of cellulose for dyes and finishes. Singeing is the first process to which the grey cloth is subjected. The warp and the weft yarns are made up of a large number of short fibers by a process of spinning, and hence the tiny fibers protrude from the surface of the yarn. The cloth woven from such yarns also has a protruding fibers, and these are removed by the process known as singeing. The object of singeing is to remove loose, hairy fibers protruding from the surface of the cloth and to impart a smooth, even and clean looking surface. Is singeing important? Yes, singeing is important because if the cloth is not singed, it will have a matted, raw appearance that is rough and dull. Singeing imparts a clear, defined and sharp design to the cloth in printing, and it reduces spilling. There are many methods of singeing, but majority people use gas singeing. In gas singeing, the protruding fibers are burnt by passing the fabric rapidly over gas flames. The machine consists of one or more burner giving continuous flames. The flame issues from a narrow slit which is adjustable with width. When the cloth is drawn over the flame at a high speed, the flame impinges on its surface and burns the protruding fibers without damaging the cloth. The singed cloth is passed through a water trough to extinguish any sparks present. You can see in the figure, the cloth to be singed A passes through guide rollers B and through brush rollers C to raise the projecting fibers, and through burners D and E where the fabric is singed, and then it flows into the water trough F to extinguish any sparks. From the water trough, it goes into the squeeze roller G, and then it passes into the steam chamber H. The next process is de-sizing. The warp yarns are sized to make it withstand the stress and strain during weaving. The major portion of the size consists of starch, wax, oil, and all these remain on the warp yarns even after weaving. The process of size removal is called de-sizing and is achieved using dilute acids or enzymes. The importance of de-sizing: it is necessary to de-size the cloth because the hydrophobicity of the wax and oils will hinder subsequent dyeing, printing, and finishing process. The objective of de-sizing is to remove the size from the grey fabric and to make the fabric more absorbent to facilitate further processes. De-sizing is mainly of two types, hydrolytic and oxidative. Hydrolytic method is commonly used and it can be done using rod steeping, acid or enzymes. Rod steeping is the oldest and it requires no special chemicals. The cloth is first soaked in water at 35 to 40 degrees centigrade and passed through a padding mangle where it is squeezed and then allowed to stand for 24 hours. The starch liquefying enzymes secreted by the microorganisms in water solubilize the starch present in the fabrics. The cloth is finally washed with water when most of the starch originally present on the fabric is removed. The other method is acid steeping, and in this a 0.25% to 0.5% solution of dilute sulfuric acid or hydrochloric acid at room temperature, that is around 30 degrees centigrade, is used to hydrolyze the starch from the sized fabric. Hydrolysis of starch is an exothermic process, so as the reaction proceeds, the temperature of the cloth rises even to the temperature of 50 degrees centigrade. The rate of hydrolysis increases at this higher temperature. The cloth is kept for 4 to 12 hours and then washed. It is an efficient and quick process, but prolonged exposure with acid will degrade the material. Next method is enzymatic de-sizing. It is the most popular and most effective method of removing starch from the fabric. Enzymes give a gentle reaction with no danger of destroying the fabric. Control of temperature and pH is very important. At temperatures more than 70 degrees centigrade, the enzymes will become inactive. Amylase enzymes are commonly used in de-sizing. The fabric is passed through two bowl padding mangles. The trough contains the enzyme bath composed of 1 to 2% enzyme, 0.5 to 1% common salt and 1 to 3 gram per liter non-ionic wetting agent. The pH of 6 to 7.5 and temperature of 50 to 60 degrees centigrade are maintained for 3 to 4 hours. Starches are hydrolyzed to water-soluble compounds by enzymes and are removed by washing. scouring. After desizing, the cloth still contains oils, waxes, fats and other foreign matters which are hydrophobic in nature, and due to the presence of these, the absorbency of the cloth is adversely affected. This leads to improper dyeing, printing and finishing. The impurities are removed from the fabric in the scouring or cleaning process, also called curing or cure boiling. The objective of scouring is to remove natural as well as added impurities which are hydrophobic in character, that is oils, waxes, fats, etc., and leave the fabric in a highly absorptive condition without undergoing chemical or physical damage. Alkaline scouring. Scouring is carried out in a boiler called a cure. The process consists of circulating hot alkaline liquor, that is caustic soda, under high pressure through a regularly packed column of desized fabric at 120 to 130 degrees centigrade for 8 hours. The scouring liquor is prepared with 2 to 4% sodium hydroxide, 0.5 to 1% sodium carbonate, 0.5% soap, 0.5% wetting agent, 1% sodium silicate with material liquor ratio as 1:4. This is a batch process. In continuous scouring, the desized fabric is passed through scouring solution and then passed into a J box where the fabric is heated with live steam at a temperature of 100 degrees centigrade for 1 hour and then washed. After cleaning, the fabric becomes smooth, neat and more absorbent. 2 important reactions are involved in scouring. First is saponification. It is a process of converting water-insoluble form of oil, fatty acids to water-soluble form using strong alkali. Second is emulsification, that is the conversion of non-saponifiable oils and waxes into stable dispersion using emulsifying agents like soap. Enzymatic scouring. An environmental friendly alternative to conventional scouring is enzymatic scouring, where an alkaline pectinase is used. This method saves water and energy and produces higher degree of whiteness. We will go on to the next step, bleaching. What is bleaching? Bleaching is a chemical process by means of which colored or discolored fabrics are made white. Natural fibers have some inherent color that must be bleached to produce white. Bleaching should be carried out carefully as a chemical may damage the fabric. The objectives of bleaching is to decolorize the natural coloring matter, to make the fabric white or colorless, to remove the stains which have occurred in the previous processes, and to make the fabric more absorbent. Bleaches can be divided into 2 groups, oxidizing and reducing. The most commonly used bleach in the bleaching industry is oxidizing bleach. The liberation of oxygen, which combines with the stain to form a colorless compound, is the principle of this bleach. In the equation, you can see hydrogen peroxide is split into water and oxygen. Chlorine combines with water to give hydrochloric acid and oxygen. Nascent oxygen, liberated, reacts with the coloring matter, decomposes or breaks up the coloring matter into simple colorless compounds. The chemicals used in bleaching are sodium chloride. It is less harmful to the fiber. Sodium hypochlorite, which is an ideal agent for bleaching cotton. Hydrogen peroxide, which is the least injurious bleach. Chlorinated lime, chlorine, and a commercial preparation of Javel water could also be used. Hydrogen peroxide is the most commercially used bleach. It is suitable to all kinds of fabric, and it is called the universal bleaching agent. Less weight loss, less water requirement, superior fastness, increased absorbency of fabrics, safety, less tendency of yellowing are the advantages of this bleach. As we saw earlier, hydrogen peroxide splits up into water and oxygen, and so coloring matter is oxidized. The action takes place most rapidly with alkaline solution. Addition of stabilizer such as sodium silicate is required as it fixes the pH value of the bleach liquor and produces good peroxide stability for efficient bleaching. The bleaching solution is made of 3 to 4% hydrogen peroxide, 1% soda ash, 1% wetting agent, 3% sodium silicate, 0.4 to 0.6% sodium hydroxide. The temperature is maintained at 100 degrees centigrade. The pH is maintained between 10.3 to 10.8. The timing is for 1 hour and the material liquor ratio is 1:4 to 1:5. In continuous bleaching, the fabric is passed through a saturator where it is impregnated with a bleaching solution. The fabric that leaves the saturator is squeezed by a set of rollers to remove the excess chemical and to ensure proper penetration of the bleach liquor. Then, the cloth passes into the heated tube where it is heated using dry steam at atmospheric pressure. The heated cloth falls into the J box, which is a large stainless steel box large enough to hold the cloth to be processed for an hour at the operating temperature of boiling point. The heated cloth is taken out from the J box and fed into the washer where it is thoroughly washed. The next step is mercerization. Mercerization is a chemical finish where cotton is treated with concentrated solution of sodium hydroxide under tension. When the cotton ball bursts, the water in the fabric dry out and the fiber collapses into a twisted or convoluted flat ribbon. When treated with strong solution of caustic soda, the cotton fiber swells up to the same diameter that it had while growing in the ball and shrinks longitudinally. The objectives of mercerization are to improve the luster of the fabric, to increase the dyeability, to improve the brilliancy of shade, to increase the tensile strength of fabric, and to improve the pliability and elasticity of the fabric. The mercerization process involves treating a fabric or yarn with a concentrated solution of sodium hydroxide, caustic soda, 18 to 24% at room temperature for 30 to 45 seconds. The chemical penetrates into the cotton fiber, causing it to swell rapidly, giving them a round cross section that reflects light to create a gloss or sheen. The natural twist of cotton fiber is removed. The swelling action causes the cellulose molecules to rearrange to produce a more open internal structure, leading to a fabric with improved moisture absorption properties, increased dye or color yields, and improved chemical reactivity. Mercerization increases the tensile strength of cotton fiber by as much as 20%. The chemical finishes show improved performance on mercerized fabrics. The mercerizing machine, the fabric is saturated with the mercerization chemicals in A and passed through rolls to squeeze out excess chemicals. Adequate tension is imparted to the fabric and sent to the stenter D. The selvages of the fabric are gripped by 2 parallel clips or pins in the stenter, and the fabric is pulled to required width and tension is maintained to ensure optimum results. When the process is complete, the chemicals are washed while still under tension by countercurrent washing system E. It operates reusing water flowing in the opposite direction to the fabric movement. Fresh water is sprayed over the fabric in the last washer E3. The washed liquor is collected beneath and sprayed over the fabric in the last before washer E2. The process is repeated so that the dirtiest water is used in the washer E1. In the recuperator F, it is again washed with fresh water. Hope you have become familiar with the preparatory process of cotton. Now, we will look into the next fiber, wool. Wool is an animal hair fiber that includes impurities from the body of the animal as well as from its environment. So it is much dirtier than cotton. The raw wool is composed of 50 to 60% protein, which is the actual wool fiber, 10 to 20% dirt, 6 to 8% soot, 10 to 15% grease, 5 to 10% plant matters, and 10 to 12% water. So, we can see nearly 50% of the weight of the raw fiber is impurities. The high percentage of impurities necessitates that wool be scoured in fiber form before it is processed into yarn or fabric. The preparatory process for wool includes scouring, bleaching, and carbonizing. Wool scouring. Raw wool is steeped in water at temperatures of 32 to 42 degrees centigrade to remove the water-soluble soot and other heavy dirt particles. Wool, we know, is sensitive to alkali, and so the water-insoluble wool grease must be removed by treating in a mixture of mild detergent or soap and a mild alkali such as soda ash or sodium carbonate. The temperature of the bath should be maintained below the boiling point. Agitation of wool should be gentle, otherwise felting will occur. Wool is bleached with 0.3 to 0.6% hydrogen peroxide. The pH is adjusted from 8 to 9 and temperature is maintained between 50 to 55 degrees centigrade. Wool carbonizing is the process applied to wool for removal of burrs and other vegetable impurities in wool. Woolen fabric is impregnated with 4 to 7% sulfuric acid and then oven dried at 100 to 104 degrees centigrade. The acid degrades the cellulosic impurities, and during drying, water evaporates, so acid becomes concentrated and it chars the impurities. The fabric is then passed through pressure rollers to crush the solid carbon residues, which is loosened and removed from wool by passing the fabric through mechanical agitators. The fabric is then rinsed with water and passed through baths containing 0.25% sodium carbonate solution to neutralize the residual acid, washed again and dried. Biocarbonizing is a process where goods are treated with cellulase enzyme instead of acid to remove vegetable matter. Silk, the queen of fibers, is a protein fiber similar in chemical properties to wool but has much lower impurity content than wool. The composition of silk is 70 to 75% of fibroin, 25 to 30% sericin, 2 to 3% waxy substances, 1 to 1.5% of natural colors, and 0.5 to 1% mineral matter. Degumming or scouring of silk is the first process. The process of removal of natural gum, that is sericin, from silk is known as degumming. Degumming of silk is usually carried out under mild alkaline conditions using soap or protease enzymes. Degumming imparts luster and softness to silk. Degumming with soap is the most commonly used method for degumming. Traditionally, olive oil soap, known as Marsley soap, is used. The temperature is maintained at 90 to 95 degrees centigrade for 1 to 2 hours. Sometimes sodium bicarbonate or sodium carbonate is used along with soap. Then the fabric is washed with hot and cold water to remove the hydrolyzed gum. The alkalinity of soap and its detergency action hydrolyzes sericin and also removes natural waxes and oil stains. Enzyme degumming. The protease enzymes act on protein, that is sericin, and convert them into water-soluble amino acids. The degumming operation is carried out in two steps. One is the removal of sericin using 1 to 2 gram per liter trypsin enzyme. The treatment is carried out at 50 to 60 degrees centigrade for 45 to 60 minutes, followed by hot water washing. In second step, natural waxes and oil stains are removed by treatment with 1 gram per liter soda ash at 80 to 90 degrees centigrade for 20 minutes, followed by cold water washing. Bleaching. Naturally, silk is cream in color. If white silk is required, then bleaching with hydrogen peroxide is carried out. Degummed material is entered at 75 degrees centigrade in a bath containing 15 to 20 ml hydrogen peroxide and 2 gram per liter sodium silicate using material liquor ratio 1:20. The temperature is raised to 80 degrees centigrade in 1 hour and the material is worked for 1 hour, then rinsed in warm water and cold water and then dried. The pH is maintained at 8.5 to 9. The next fiber is rayon. Rayon is a manufactured fiber and so does not have any inherent impurities. Rayon does not require to be bleached unless bright shades are required. Viscose rayon. Oil and grease which might have been accumulated during weaving or knitting is removed by trichloroethylene and rust marks by treatment in ammonium oxalate at 50 degrees centigrade for 20 minutes. It is bleached for 1 hour in cold hypochlorite solution containing 1 to 5 gram available chlorine at pH of 10 to 11. Then it is washed and neutralized with dilute hydrochloric acid and washed again. Hydrogen peroxide may safely be used on viscose rayon. Cupramonium rayon. Although cupramonium is also similar to viscose, hydrogen peroxide should not be used on it. A very mild solution of sodium hypochlorite may be used and should be thoroughly rinsed immediately. Next fiber is polyester. It's a chemical fiber and so does not have much impurity. Scouring. The impurities which have to be removed from man-made fibers are usually only oils which are incorporated during spinning and applied in weaving or knitting, as well as the adventitious dirt present. Mild detergent action is sufficient to clean these materials. Scouring can also be done with Lysopol 1.5 parts, soda ash 2 parts at 70 degrees centigrade for 30 minutes. Bleaching. Polyester does not need bleaching. It needs to be bleached only if pure whiteness is required. Sodium chloride can be used for bleaching polyester. Bleaching is carried out in a bath containing 2 to 3 grams per liter sodium chloride, 2 ml per liter formic acid, 1 gram per liter sodium nitrate. The time and temperature are 1 hour at boiling point and the pH is maintained at 4. Optical brightness can be used to give a brilliant white look. Dear friends, hope this session would have given you an insight into the different preparatory processes, namely singeing, deicing, scouring, bleaching, mercerizing, carbonizing and degumming. Thank you and bye for now.